Hello everyone, let's try to be a cheat code ninja today. Even though this problem is marked as easy, the techniques used to solve this problem will be handy in many other linked list problems. Let's look at it. In this problem, we are given a linked list and we have to return the middle node in it. And if there are two middle nodes, which can happen if there are even number of nodes in the list, we have to return the second middle node. In the first example, there are 5 nodes. The third node will be our middle element, hence we are returning it. In the second example, we have 6 nodes, so these two will be the middle nodes of the linked list, but we'll return the right one. One obvious way to solve this would be by first counting the number of nodes in the list and then finding the index at which the middle element will occur. Over here we have 5 nodes and the third node will be our middle element. For this list, we have 6 nodes and the fourth node will be our middle element. In general, we can use this formula to find the element which will be the mid of the list. This will work for both even and odd sized list. Let's look at another way which will be very handy in solving other linked list problems. In general, any linked list will have a null pointer at the end. Let's try to use this to find our middle element. In this linked list, to reach the null element from the head element, we'll have to move 5 steps. And to reach the middle element, we'll have to move 2 steps. In this linked list, to reach the null element from the head element, we'll have to move 6 steps. And to reach the mid element, we have to move 3 steps. In both the cases, if we integer divide the number of steps to reach null, we'll get the number of steps to reach the mid element. So if we can somehow travel half the distance to reach null, we'll arrive at our middle element. To travel half the distance, we can use 2 pointers. One of these pointers will move ahead by 2 steps at a time and the other one will move by only 1 step at a time. So the distance traveled by the slower pointer will always be half of the faster one. Let's see those pointers in action for our example. Initially, both of them will be at the head element. Our slower pointer will move by 1 step and the faster one will move by 2 steps. We can see that the faster one still has room to move forward, so we'll again move both the pointers. Now in this case, the faster pointer, if it moves, will land ahead of the null pointer. We don't have any room for movement, hence we'll stop, and the slow pointer will be our middle element. Let's see this in action for the even size list. Initially, both our pointers will be at the head element. We'll move our slow pointer by 1 and the faster pointer by 2 steps. We'll again repeat this. Now if our fast pointer moves ahead, it will land at the null pointer. We'll consider this to be acceptable and move forward. Now there is no more room for a fast pointer to move, hence we'll stop this process. The slow pointer will represent the middle element. The time complexity of this would be O of n because we are using 2 pointers and just traversing on the list twice. And the space complexity would be constant because we are just maintaining 2 pointers. Let's implement our solution. We'll initialize the slow and the fast pointer to be the head of the list. We'll check if a fast pointer has room to move forward. So it cannot be presently null and its next element cannot be null. Please note that we are allowing the fast pointer to move forward if 2 steps ahead is a null pointer. But if the next step is null, we don't allow it. Now we'll update our slow pointer by 1 step and a fast pointer by 2 steps. When a fast pointer cannot move forward anymore, we'll exit this loop and we can return the slow pointer as our answer. Let's submit our solution. As you can see, our solution is accepted. If you thought this video was helpful, please leave a like and subscribe to the channel. Thanks for watching.